So we're going to start our sketching activities with some translations of functions. Now that word up there, translation, just means moving the function around the graph. So later, when we start to stretch and compress them vertically and horizontally, those are transformations. So for this video, we're just going to move our basic shapes all around the grid. So I'm just going to pop that up there for you. Translations means moving things around. Now that should make sense with your normal English interpretation of the word translations. When you translate something from English to another language, you are supposed to just move the words. You just map them from the English word for cat to the French word for cat. You aren't supposed to change the meaning. So there's not supposed to be distortions when you translate from one language to another. There, of course, are. Which leads to comedy and catastrophe. But fortunately for functions, you can translate them directly without causing any issues. So if we can do our first one here, I'm going to start with a parabola, because that's one we're used to. We're going to sketch f as a function of x is x squared. Now that function has a basic pattern. And you should have done this in grade 10 many times. I'm going to map it out for you just a little bit so that we can have this pattern in front of us when I go to sketch. Every function takes x values and returns y values that we then plot on the grid. Each function has its own set of x values that it accepts and certain x values that it returns clean values for. And in order to be efficient when you're sketching, it is good to hunt for and maybe memorize certain sets of x values for each function. So if I think about this one, taking the x and squaring it, well, as long as I pick a number without a decimal, like 4, I'm going to get a clean answer out of this. 4 times 4 is 16. So I can use any number that's an integer. And if I go into the negatives, I can square a negative, right? Negative 2 times negative 2 is positive 4. So I'm just going to grab a few of them. I'm going to grab, let's say, minus 3, minus 2, minus 1, 0, 1, 2, and 3. Extend my grid here. I love how it screams when I do that. Minus 3 squared would be 9. Minus 2 squared would be 4. Minus 1 squared is 1. 0 squared is 0. 1, 4, 9. So I'm just taking this x value, whatever this number happens to be, and I'm executing this function, so squaring it. 3 squared is 9. Alright, now what I'm going to do is take this basic shape and I'm going to write one that has been translated. So if I take my new function, g, as a function of x, and I'm going to move this one 3 squares to the right. Now that means that x equals 3 has to behave like x equals 0 used to in the function. So I'm going to use some subtraction here. So whatever this number is, once I put in my x value, I immediately look 3 squares back to see where the pattern should be. I'm going to keep it squared because that's a parabola. And I also want to take this parabola and move it down 5 squares. So that's down 5. So I'm just going to add that up there for you. This is a right 3, and this is down 5. So if I were to grab an axis, the first thing I'm going to put on here is the x and y that have been unshifted. So here we go. Here's my x-axis. Except that's the y-axis. Here's my x-axis. Now, if I see that I have a rightward shift 3, I'm going to take this y-axis and I'm going to shift it 3 squares to the right. So 1, 2, 3. And I'm just going to dash in a new axis. So that is my y-axis translated 3 squares to the right. My x-axis is supposed to be translated 5 squares down. So I'm going to do that. 1, 2, 3, 4, 5. So I have a new origin to start mapping my dots from. And that's the secret to efficient translations, is to take your original origin and actually execute the translation on the axis. So you have a new place to start counting from. All that's left to do is to map this pattern onto my new axis. So I used to go 3 squares to the left to -3, and then go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This dot used to be there. But since I have translated this, instead of counting from the original origin, I'm going to count from the new origin down here. So this dot here, 3 to the left, 1, 2, 3, and up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 would be here. Now, do you notice that where it used to be and where it is now happens to be 1, 2, 3 to the right and 1, 2, 3, 4. Apparently I can't count. 1, 2, 3, 4, 5, 6, 7, 8. That should be here. Let's try that again. Notice that this point dot that used to be here is now here, and it happens to be 1, 2, 3 to the right, 1, 2, 3, 4, 5 downward. So by moving the origin and counting from here instead, I'm going to end up taking all these dots and executing the translation on them. So my next one here, -2 and 4, -2 and 1, 2, 3, 4, -1 and 1, -1 up 1, 0, 0 stays right on the origin, 1 and 1 would be here, 2 and 4 would be here, 3 and 9 would be here. This is not part of my graph. So I just have to sketch in my parabola here, trying to be nice and smooth. And there you have it. This parabola is the sketch of this function, which is the basic parabola function. I can tell because I have a square here, shifted 3 to the right and 5 down. The next one we're going to do is basic exponential, base 2. So as with the parabola, when I'm doing any sort of sketch, I need to remind myself what the basic pattern is. So exponentials have this big long tail, and then they take off really quickly. So I need a few x values that will lie in the tail region, and I need a few that will lie in the taking off region. So the tail is in the negatives. Now I can put any negative in there I like. I can put any number in there I like. I'm going to get powers of 2. So I'm going to go with -2, -1, 0, 1, 2, and 3. Doesn't matter which ones you use exactly, as long as you get some that are in the tail region and some that are in the taking off region. So those are my x's. This is the value of the function. If I put a negative 2 up into that exponent, I get 2 to the negative 2, which is 1 over 2 squared, which is 1 over 4. If I put a negative 1 in this exponent, I would get 2 to the negative 1, which is just 1 over 2. 0 in that exponent, anything to the exponent 0 is 1. That's that. 2 to the exponent 1 is 2. 2 squared is 4. 2 cubed is 8. So on and so forth.
Good morning, Washington Riverhawks. Please stand for Kansas.
So we're going to translate this function. This one, I'm going to try moving to the left and down. So if you think about that, inside the operator of the function, there should be a positive in order to move it left, and a negative on the outside moves it down. So let's do g as a function of x is 2 to the x plus 4 minus 6. So a positive up inside the operator is a leftward shift. So I'm going left 4. And a negative outside is a down 6. So I'm going to grab myself an axis. I'm going to draw the x and y axis on there. There's my y. These markers are getting tired. There's my x. Now I'm going to take this leftward shift and I'm going to take my y-axis and shift it 4 squares to the left. So 1, 2, 3, 4 would be here. And I'm going to take my x-axis and I'm going to shift it down 6. So 1, 2, 3, 4, 5, 6 would be here. So that's going to provide me the scaffolding on which I will build my pattern. So measuring from the new origin, if I go 2 squares to the left, I'm supposed to be only 1/4 of a square up. So that would be about here. 1 square to the left, I'm only up 1/2. No squares over, I'm up 1. 1 square over, I'm up 2. 2 squares over, I'm up 4. And 3 squares over, 1, 2, 3, I'm up 8. 1, 2, 3, 4, 5, 6, 7, 8. And so you can see that exponential pattern forming. So I'm just going to draw in my horizontal asymptote and then swoop up through my dots like so. So I have this basic exponential pattern, base 2, that has been moved from the original origin, left 4 and down 6. So we need to do one that's gone left and up, so I'm going to choose a logarithm for that one. So we're going to go with f of x equals, let's go with log base 10 of x. So I'm going to choose some critical values for this x here, ones that will give me nice values for a logarithm. So the basic log has a vertical asymptote at x equals 0. So I'm going to write that in here, 0, and then there's going to be a vertical asymptote. So something that you just need to know is that if x has a value of 0.1, then log of x would be negative 1. If x happens to be 1, then the log of 1 is 0. You can do all of these things with your calculator, right? Log of 1 is 0. And then the next nice number for log base 10 would be 10. Log base 10 of 10 is 1. The next number that's clean for logarithm is 100, and that is not going to fit on my graph. So I only need to worry about these 4 dots when I'm doing the sketch. And the one I'm going to sketch, what do I say, left and up. So let's sketch g of x is log, moved left, 6, and up 2. So again, I'll write that in for you. A positive inside the operator is a leftward shift. Left 6. And a positive outside the operator is an up 2. If I grab my grid, I'm going to put the unaltered x and y axis on there. There's my y. There's my x. I need to translate this y-axis 6 to the left. So 1, 2, 3, 4, 5, 6. And I need to translate the x-axis up 2. 1, 2. So when x is 0.1, so if I go 0.1 over from my new origin, I should be down at negative 1. So that's about here. When I go 1 to the right of my new origin, I should be at 0. And when I go 10 to the right, I should be at 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Should be there like that. Last little feature to add in is that there should be a vertical asymptote at 0 on my translated axis. So I'm just going to draw that in, vertical asymptote, and then swoop over here. Something like that. So I have that classic logarithm pattern, but it's been moved 6 squares to the left and 2 squares up. So I need to do a translation of one that has been moved rightward and downward. So for that, I'm going to choose the rational function. So f of x is 1 over x. So I'll make a little table for my basic pattern. So this function returns fractions for all values. So I just need to pick some fractions that I think I'm going to be able to sketch. So I think negative 3, negative 2, negative 1, 1, 2, and 3. Those are all fractions I can sketch. And then there's this place in the middle, which we're all remembering, is if I do 1 divided by 0, that gives me a vertical asymptote. So 1 over negative 3 would be negative 1/3. 1 over negative 2 is negative 1/2. 1 over negative 1 is negative 1. 1 over 1 is 1. 1 over 2 is 1/2. And 1 over 3 is 1/3. So since we need to translate this rightward and downward, let's sketch g as a function of x is 1 over x minus 5 minus 7. So a negative inside of the operator is a rightward shift, and a negative outside the operator is a downward shift. So if I grab my grid and put on my untranslated axis, there's my x, there's my y. This function is to be shifted 5 to the right, so take my y-axis and move it 1, 2, 3, 4, 5 to the right. And 7 down, so 1, 2, 3, 4, 5, 6, 7. Filling in this basic pattern, 3 to the left from my new origin should be up, or down because it's negative, should be under by a third. 2 over should be under by a half. 1 over should be under by a 1. 1 to the right should be up 1. 2 to the right should be up a half. 3 to the right should be up a third. And I have to draw in this vertical asymptote at 0. So for this branch, the only way to do that is to swing up and follow the y-axis this way. Like so. On this side, the only way to do it is to swing down and follow the y-axis. Like so. And then the rational expression continues onward out here, getting closer and closer and closer to the x-axis, to the translated x-axis, as a horizontal asymptote. Here we go. So here we have a graph of the basic rational function, but shifted rightward 5 and downward 7. I'd like to make sure you have an example of each type of function. So I still need to do a rational expression, and then, a radical function, and then I need to do one of the sine or cosine curves. So if we start with the radical, f of x is the square root of x. Now you know that you can't put a negative into a square root, so I'm not going to be putting any negatives into my basic pattern, but you can square root 0, so that's where I'm going to start. I can square root 1, the square root of 1 is 1, so that's a tidy point to use. Square root of 0 is 0. But I can't square root 2 or 3 without getting a decimal, so I'm going to skip them and go straight to 4, because the square root of 4 is 2. Then I'm going to skip 5, 6, 7, 8, because they don't have clean square roots. I'm going to go straight to 9. Square root of 9 is 3. And then the next perfect square would be 16, which I suspect I'm not going to get on my graph, but I'll put it there just for completion. Square root of 16 is 4. So there are the dots from my basic pattern. So this one, we're going to sketch this. I'm going to give you a minute to look at that function and ask yourself, based on this, is this a left, a right, an up, or a down? So inside of the operator, that's the horizontal stuff. So it's not an up or a down. And if it's positive inside the operator, it is a leftward shift. Hopefully you got that. Left, 5. This one out here, I'm going to give you a second to think about it. So that's a down 3. So I'm going to fetch myself a grid, put on my untranslated axis, My y-axis needs to be shifted 5 to the left. So it's 1, 2, 3, 4, 5. And my x-axis should be shifted 3 down, 1, 2, 3. So now that I have my new origin, I just need to map this pattern. So on the original origin is a dot. 1 to the right, up 1. 4 to the right, up 2. 1, 2, 3, 4, 1, 2. 9 to the right, up 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Notice that I am counting from the new origin, from the new x-axis, from the new y-axis, not from dot to dot. 16 to the right, up 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Haha, just fit. 2, 3, 4. Perfect. So I just have to draw in that beautiful square root curve, which looks an awful lot like a parabola that's fallen over and been cut in half. And there you have it. A lovely radical function that has been shifted 5 to the left and 3 down.
I'm going to sketch a translated cosine function. So when I set up the grid here, I'm going to set up the grid a little differently. It still will have an x-axis, like so. And it will still have a y-axis, like so. But these things don't shift 1 unit or 2 units, 5 units left and right. They shift in degrees. And the degrees, if you do a full cycle, that's 360 of them. And if I go 1, 2, 3, 4, 5, I'm never going to get to 360. So I'm going to set my grid up going in 30s. So, 30-degree steps in this direction. So that would be not 1, that would be 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360 would be here. And if I go the other way, 30, 60, negative 90, 120, 150, 180, 210, 240, 270, etc. Okay. Now, for reasons that will seem mysterious right now, but will make more sense once you stop sketching in degrees and start sketching in radians, I'm going to use 0.5, steps of 0.5 as my y scale. It's going to make the curve a little taller. It's going to make it a little easier for me to see how it actually curves. So that will be 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, negative 1, negative 2, 5. Okay. So now that my grid is established with a scale that will actually let me see the whole shape here, I'm just translating like I have every other function. That right there is telling me to go right 60 degrees. And that there is telling me to shift it down 2. So 60 degrees, 30, 60 would be right here. Draw myself a dashed line. And negative 2 is here, so I'll draw myself a dashed line. And now that I have that translated, I just have to map the cosine pattern on there. So a cosine pattern fits in a box, like so. There's a midline, and there's a maximum for the wave, and there's a minimum for the wave. And the pattern for cosine is that within this rectangle, it starts high, it ends high, it bottoms out exactly halfway, and then it crosses the midline exactly halfway between these two things. So you end up with a full cycle, which is 360 degrees, cut up into four equally sized chunks. So the first thing I'm going to do on my translated axis here is I'm going to establish the rectangle. So it goes one up from the midline and one down from the midline. So here's my translated axis. I'm going to draw this here. I have some scaffolding. That's where all my peaks are going to land. One under will show me where all of my troughs are going to land. And I just need to know how long this rectangle is. So it should be 360 degrees long, counted from my translated line. So if I were to take 360 degrees, I think that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 12 squares on this scale I've chosen. And I count 12 squares from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to draw a place to stop. Now this function keeps going forever, so once I've built one triangle, I need to build another one rectangle, I need to go that way, do another one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have two rectangles set up. I have one here, and I have one here. And into each of those boxes, I have to map this pattern. So pick a rectangle. I'm going to choose this one. Inside this rectangle, I have to start high, end high, bottom at dead center, and then cross the midline halfway between those. Should be about there and there. Do the same in the other box. I have to start high, I have to end high, I have to hit the bottom dead center. 1, 2, 3, 6. Hit the midline halfway between those, hit it halfway between these. And I've got enough dots there that I can sketch in my cosine pattern. And of course, it goes on forever. So there's no difference between translating a cosine and any other function. That's still a rightward shift. That's still a downward shift. Your choice of scale is a little different because you are shifting 30s, 60s, 45s, not just 1 and 2. So once you get this scale established, hopping by 30 degrees and hopping by half a degree, or half a unit, sorry, in the y direction, once you map that pattern on there, you get a nice wave where you can see all the curves.